So can you see this plate here? Can you see the line here?
Yes, sir. Yes, sir.
Yeah, this plate is basically the special alloy resistor. So this plate is one resistor. I'm having how many plate here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Around 17 plates I'm having here. So there are 17 resistors connected in series. Okay.
Okay, sir.
There are 17 resistors connected in series, and each of these resistor has to be maintained some distance from the other resistor. Okay. I think Mr. Verma also joined. Fine. So now, see here, NGR, several steel strips are there, or you can have punched steel plate or grid. Number one. Number two, the enclosure is made of sheet steel, and in-case protection should be suitable for outdoor or indoor. Then very important point, resistance material should have low resistance temperature coefficient. Okay. Can you tell me what is the temperature coefficient value? I will tell you later on when I take up NGR material, and I will give you one small exercise also. So if you have your calculator or Excel, you please keep it handy. I'll give you an exercise after some time. Now, the insulation, ceramic, mica, porcelain, any epoxy, any other kind of insulation you have come across?
Varnish.
Okay, varnish is actually, yes, that is also paper varnish, also insulator. But I am asking to hold the plate.
That would be porcelain, I would say. Porcelain ceramic.
Okay, porcelain, ceramic. Then cooling is natural because reliability is a question here, and that is why I don't want a fan inside. Okay, and since cooling is natural, the NGR size will be bigger. Okay. Clear? Any doubt related to construction of NGR?
No, sir.
Okay. Then coming to ingress protection, as I told, ingress protection and cooling are related. If ingress protection is very strict, like IP55, cooling will become very difficult. Okay. And if my IP is very less, then there can very low IP also, then some foreign body can go inside. So normally utilities are recommending what? IP32. IP32 they are recommending. What is IP32? What is the Mr. Armugam? What is IP32?
IP32 will be first letter is for the dust, which means I should not be able to enter with any tools.
And
Two will say that any dripping water it should be capable of extending.
correct. The first digit 3 corresponds to this one. Hand,
Finger.
uh, hand, finger, screwdriver. Tools should not go inside.
Tools.
Correct.
Yeah, tools.
Tool should not go inside. Now the second digit, if it is 2 or 3, what does it mean, Mr. Pinaki Sharma? Second digit 2 or 3?
Means it can take some kind of water for but not with forced snow thing. It is like splashing. It will not take, but
Okay.
something like that, sir.
Zero means no protection. One means dripping like rain. Two
Yeah.
means 15 degree, like a slashing rain. So three means spray.
Rainwater.
So IP33, I think IP33 is good. IP32 also is okay. Okay.
Mm. Mm-hmm.
Normally, IP, see, some people will specify, if you specify IP55, then
Mm.
your size and cost will increase.
Mm.
If you specify IP32 or 33, I think it is good enough. Okay.
Mm.
Because the IP32, 33, fine. You will not get into any problem. See, the thing is here we have to make it is something like we have to decide. Very
Mm.
big IP, my cooling will become a big headache. Very low
Mm.
IP, if I keep outdoor, then some snake or something may go inside. So I think IP32 is a good choice. Okay. Then see, you can have NGR either for a generator. See here, SLD, NGR is for a transformer. In this SLD, NGR is for a generator. When I
Generator.
keep a NGR for a generator,
Mm.
actually that time you can locate it indoor. Okay. When the NGR is for a transformer, you can locate it outdoor. And if you are locating indoor, please put one barricade. Then see, if you have separately, if you are having some relay in the NGR or something, monitoring relay, then that region, please bear in mind, one is it should not be subjected to the temperature rise of the NGR, okay? Because otherwise your relay may get damaged. And when I talk about relay here, I'm mainly talking about the monitoring relay, the relay which will monitor the healthiness of the NGR. And that region you should have high ingress protection also, because say electronic equipment, if any dust get inside, it can get damage. This one, see, this actually all, see, when I prepared all this guideline, I have actually spent close to 3 years in preparing all these guidelines, and I have referred more than some 200 plus research publication. More than 50 vendors I have contacted, taken input from them and developed all this. Okay. So I've taken input from the actual vendors. And it is not like go to internet, go do search, copy, paste and do. So these vendors have actually supported and have developed the guideline, the material. So this German vendor, Hein registers, okay, this is the grid. Then we use a plate instead of a bound material. Now coming to NGR material. See, the material of NGR will be steel, no doubt, but the steel has to be a special alloy. Why not copper, Mr. Why not aluminum,
Mm-hmm.
Mr. Armugam?
Uh, because those two are very good conductors,
Okay.
and the resistance temperature coefficient is the temperature will increase very rapidly.
One point you told, they are very good conductor. Yes, that is the big reason.
Yes, sir.
See, if I go for, let's say, copper, to get some, let's say, particular resistance, let's say I want a resistance of 100 ohms. then I will need huge amount of copper.
Hmm.
So
Cost will increase.
yeah, so steel is good. Steel will give me more resistance. But the steel which is used in NGR is a special alloy. What is the speciality? Positive resistance temperature coefficient will be such that it will be low. In other words, when there is a rise in temperature, resistance
Hmm.
will not increase much.
Much.
Okay. Negative temperature coefficient you will find in semiconductors.
Hmm.
Then the material you all told material should not corrode. Same thing I have also written here. Why material should not corrode? Because if there is a corrosion, what will happen? You see here, see the small plate. The small plate here, if it get broken, all these are in series, right? My entire resistance is gone.
Hmm.
So corrosion is a serious thing. My resistance has become very high also. It is a crack.
Hmm.
So that is the reason I have to choose the material in such a way that corrosion will not take place, and also space heater is required inside so that moisture will not accumulate. Then what are the, see, these are the steel classification. Some of the vendors are giving AISI 304, AISI 310, AISI 430, nickel chromium steel. Okay, these four I have come across. But my suggestion to you, when you are making a specification, please don't mention the material. Allow, let the vendor decide. You can only ask the vendor what is the material you have used. Okay. Then stainless steel 316, the normal steel what we use. Please don't use that. Why? Mr. Pinaki Sharma, why
Temperature.
temperature?
Temperature.
Yeah, what will happen if I use my normal steel?
The resistance will increase when the temperature increases. So you have to use an alloy.
Later on, you can check and you can post in the group what is the temperature coefficient of the normal steel.
Hmm.
Okay, please post it in the group so that we can have a look. Then, see, material is developed by the vendor after a lot of research. So leave it to the vendor. Okay, don't
Hmm.
decide the material.
Hmm.
Now, let me come to this temperature coefficient.
Hmm.
See, I have explained you that when temperature rises, resistance increases. That is what is positive temperature coefficient, right? And
Hmm.
where do you come across negative temperature coefficient?
Transistors.
In the transistors. Now let's say I have a resistance of 100 ohms. Okay. Now let the ambient temperature be 30 degrees Celsius. Now, when the fault takes place, current will flow, temperature will rise. Let's say the new temperature is 330 degrees Celsius. So what is the rise in temperature? 300
Hmm.
degree, right?
Yes, sir.
Hmm.
300 degree. Now let's say my temperature coefficient is 0.0009. That is my ordinary steel. What will be the new resistance? Can you calculate and tell? Though I have the value here, can you calculate yourself and tell me from 100 ohms what will be the new resistance? Please do the calculation. Take the time and please tell me what is the value. The- don't see what is there here in the screen. Please do it on your own.
127.
Okay. All of you are getting the same value or you're getting different value?
Same value. So
Yeah, same.
Mr. Armugam, you also got same value?
Yes, sir, same.
Okay, now suppose I let's take 3.3 kV, 3300 volts, and divided by 100 ohms. What will be my current?
100 amps,
33 amps. Okay.
33 amps. Excuse me.
Now the same 3300 volts divided by 127 ohms. What is the current?
25.
25.
26 amps. 26 amps.
26.
So what is happening? Current is coming down, right?
Hmm.
Yes.
Okay, now imagine that at 33 amps my relay is able to pick up. At 25 amps my relay will not pick up. So if I go for normal steel, what will happen? My NGR, see this is at 330 degree. Now if the temperature had gone to, let's say, like this, my specification I had given, no?
Hmm.
610. Take 610 degree and tell me what is the resistance, or take 630 degrees. 630, what is the new resistance? It will be 600. You have to only substitute 600 here. 600 into this coefficient.
154 ohms.
How much?
154 ohms.
Okay. So everybody got that value?
Yes.
Yes, 154. Yes.
Okay, now divide 3000 or 3300, you divide by 160 or 154 ohm. How much you are getting?
21
21.4.
point, 21.4 amps.
Okay. So your fault, what was the fault current previously? 33 amps.
33 amps.
So it became almost 20 amps, right?
Yes, sir.
What happens? See, this is the problem. If the material is not selected properly,
Hmm.
the fault current will reduce to such an extent that it is as good as NGR has failed in its duty, right?
Hmm. Hmm.
Yeah.
See, NGR has brought down the fault to a very low value. Fine, that is good. But my relay will not be able to sense the fault. Then what will
Hmm.
happen? Relay will never trip.
Hmm.
Then it will lead to a fire, right? Continuously fault is there. See, though the fault current magnitude is less, somewhere it is leading to an arcing and it is there continuously for a long time. It will lead to a fire. So it is a safety problem also. So that is the reason the material of the NGR, you have to be very careful. So you have to ask your vendor when you are buying to give all the test certificate and verify it. Okay? Then one more thing, see, this is basically a resistance, right? There is one more thing is there is a capacitive reactance present inside. See, capacitive reactance is there in capacitance is there in everything, motor or a cable, everything. And this resistance
Hmm.
and capacitive reactance, what will happen if the NGR resistance become very high? It will become like an unearth system also. And if it
Hmm.
become like an unearth system, it can lead to a high voltage buildup. Okay. I told some of the material here. No, what was those material? AISI 304, 310, 340 nickel chromium steel. Do you know what is the temperature coefficient of those material?
Steel is 0.003.
0.003, yeah? Okay. So you can, any of the material temperature coefficient, if you're having, you please share it to the group. It will be a good knowledge sharing. So my request is, all these things if you share, you are not, see, the learning will not stop here. If you share, maybe over the next 1 week, whatever you get, try to do small research, and whatever I have been telling, try to get them and share it in the group. Okay? Then learning will continue for another week. Okay?
Okay.
Like try to find out NGR, what is the positive temperature coefficient, typical value, what you have come across. Go search some of your old project documents. Okay. What I got was 0.0002. My normal scale was 0.0009, and this is almost one fourth of it, 0.0002. You can also
Um,
search, if you know some vendor, you can call him and ask him what is the positive temperature coefficient you are using. Now, can you substitute 0.0002 here instead of 0.0009 and tell me what is the value of resistance? Just do the calculation. Though it is there here, I want you to do. Your temperature ambient is 30, your final temperature is 330, your positive
106.
temperature coefficient is 0.0002. Okay, your resistor is 100 ohms resistor. What is the new resistance due to the heat generated?
106.
You're getting 106. All of you getting same?
yes, sir. Yes, sir.
You see, okay, now divide 3,300 by 106. How much you're getting?
31.13.
31.13.
31?
0.13.
31.13. Yeah.
So 33 amps became 31. That means there is a reduction of 2 amps. Means almost like less than 10% reduction. So that is okay. If 33 amp become 31 amp, it is okay, not a problem. But if 30 amp become 20 amp, then my relay will not be able to sense the flow. So now I hope you understood the importance of NGR. In NGR, what is important in NGR? See, you all are basically, you are not a equipment design engineer, right? You are not going to design any equipment. You are all application engineer or project level people. You are going to buy something from somebody basically. And at the end of the day, when you buy something, you should know what he is giving, whether what he is giving is correct or not, and how do I specify, how do I verify, right? That is what you should know. So when somebody supply you NGR, one important thing is you should know the material. What material he is giving, what is the positive temperature coefficient of that material, and why positive temperature coefficient of the NGR is important, I've explained you. Okay. Then see IEEE 32. What are the standards we came across here? We came across different standards, right? IEEE 32 is one of the prominent standards. See, in this standard, it is recommended that the positive temperature coefficient has to be below 0.000263. Okay, it should not be above that. Now coming to NGR failure. Can you tell me what do you mean by failure of NGR?
If the resistance is open circuit,
The resistance. See, when you say failure of any equipment, I say failure of a motor. What do you mean by failure of a motor?
It is not functioning as it is required.
So when you say not functioning in a motor, what will happen to the winding, motor winding?
It'll get burnt, it'll get heated up.
Motor winding will get burnt and heated up. Okay. And let's say I have a building, a
Hmm.
house, or any factory, any building. Then we will say failure. It is usually a short circuit, right?
Mhm.
Transmission line. When I say failure, it can be two things. It can be due to wind, it can be a short circuit, or conductor may snap. Yesterday, one of you told snapping of conductor, right?
Mhm.
So when I say failure, failure can be a open circuit or failure can be a short circuit. But actually, failure, see, failure, when there is a failure, the problem of open circuit is a big problem than short circuit. Okay, because in case of your NGR, short circuit will not happen. Okay, it is more a problem of open circuit, right? You see here, if this one corrode, let's say this particular plate got corroded. Now if this particular plate got corroded and this one small strip of metal, if it breaks, what will happen? Are you able to,
Resistance will rise.
pardon?
Resistance will rise.
It is a open circuit. Can you,
Open.
will you do you foresee a short circuit problem here?
Short circuit. Yeah, there could be.
if something gets into in between, maybe short circuit can happen, but not a complete dead short. Resistance will reduce.
See, if this particular porcelain insulator fail, what will happen? I am having 17 resistor. Mr. Mr. Pinaki Sharma, what is the problem? Sir, hold on. I think is Mr. Pinaki Sharma.
He's saying he's not able to hear.
Pardon?
He's not able to hear, he says. He has messaged in chat.
I think his problem in is this one.
Yeah,
Others are able to hear,
I
right?
can hear. I can hear.
Yes.
Others are able to hear. See, others are able to hear. Only Mr. Pinaki Sharma is not able to hear. I think he dropped
He
out.
will rejoin. He will rejoin.
Okay, now see here. See, when I say the failure of NGR, one big problem. Okay, hold on. Mr. Pinaki Sharma able to hear now? Mr. Pinaki Sharma, are you able to hear now?
Now I'm able to hear, sir. I think I had to log out and log back in.
Okay, see, basically what we are discussing now is what do we mean by failure in a NGR? Okay, when we say
Hmm.
failure in a NGR, you see the plate here may get corroded and broken, so it will be
Hmm.
basically an open circuit. Okay, just like a transmission line snapping. Then the
Hmm.
other problem is this porcelain insulator can get, it can get carbonized. Then
Hmm.
out of the 17 resistors in series, it may become 16 resistors in series. So that is not such a big problem. Actually, short circuit is not a big problem here. Okay. Open circuit is a very big problem here in a NGR failure. Okay. So open circuit is a much big problem here. And so I will stop here now in the evening session.
Hmm.
Okay, I will take up on this one. I will explain you about this relay monitoring of NGR. Then I have this relay also. I will open and show the relay to you. I have the picture of the relay. I will open that and separately show. And then some NGR pictures also I'm having, that also I will show. And other things also we can discuss. So any doubt till here?
No, sir.
No, sir, it is clear.
Okay. So evening 5 o'clock, that time we'll take up this failure.
Hmm.
Okay, we will take up